Hello everyone. In this module number 7, we will study formation of compound with incongruent melting point. So basically we should know what is meant by the incongruent melting point. There are compounds whose stability does not extend to their melting points. Hence, these compounds on heating undergoes incongruent fusion and are therefore said to be possess incongruent melting point. Now, in this topic, one of the important term is a peritectic reaction. So what it mean? When compounds are heated, they decompose to produce a new solid, and the solution or melt of composition different from that of the solid phase, and this decomposition is known as peritectic reaction. Now, it is represented as this reaction. So, in this reaction, the C2 is the compound undergoing incongruent fusion and the C1 is the new solid phase form. Along with this, solution or melt is formed. The best example of such a system is CaF2CaCl2 system. This is a phase diagram of CaF2CaCl2 system. In this phase diagram, this line is showing the composition of the two compounds, namely CaF2 and CaCl2. In this point is the 100% CaF2 is present, and at this point the 100% CaCl2 is present. So this line is showing the various composition of these two compounds in a percentage, while this line is showing the temperature parameter. In this phase diagram, the different curves, different points and different areas are present. So, we will discuss in briefly the curves, points and the areas. So, let's start with the curves. In this phase diagram, three different kind of the curves are present. The first curve is a curve AB, second is a curve BD, and third one is a curve ED. So here in this phase diagram, these three curves are present. Now let's discuss each and every curve detail and apply the condensed phase rule for each curve. So let's start. The first curve is a curve AB. In this phase diagram, this line is showing the curve AB. So the curve AB, it is a fusion curve of CaF2, in which the solid CaF2 and melt are in equilibrium. So here you can see the CaF2 plus melt is there. So at this curve, the solid CaF2 and melt are in equilibrium. Now application of the reduced phase rule. We know the reduced phase rule formula, that is F is equal to C minus P plus 1. If we put the value of these C and P, that is a number of component and number of phase, in this reduced phase formula, we'll get number of component value is 2, phase number of phase is 2 and 1 is as it is, and it's equal to the 1. Means the value of the degree of freedom is found to be 1. Hence, the system or the curve AB is a univariant in nature. Now next is a curve BD. In this diagram, this is a showing the curve BD. This curve BD, it is solubility curve of CaF2CaCl2, in which the solid CaF2CaCl2 is in equilibrium with liquid phase or the melt. After application of the reduced phase rule, we will get the F is equal to 2 minus 2 plus 1, that is equal to 1. Hence, the curve BD is known as a univariant curve, or the system is a univariant at curve BD. The next curve and the last curve is a curve ED. Here in this phase diagram, this is a curve ED is there. Now, the curve ED is the freezing point curve. It is a freezing point curve. It shows freezing point of CaCl2 decreases with addition of CaF2. As the line goes on decreasing from right to the left, as we move from this addition of these takes place, addition of this CaF2 takes place here, and due to the addition, the freezing point goes on decreasing. The solid CaCl2 and melt are in equilibrium. Now, application of the reduced phase rule. Here, F is equal to C minus P plus 1, that is equal to 2 minus 2 plus 1. As here, the number of components are 2, that is a CaF2 and CaCl2. Number of phase are again 2, that is solid and the liquid, and 1 is as it is. We'll get the value of the F is equal to 1. As the value of the F is 1, that is a number of degree of freedom is 1, then we should say the curve ED or the system is a univariant. After whole discussion about the curves, we will move towards the points. So in this phase diagram, there are two different points are present. The first is a point B and second one is a point D. This point B is there and point D is there. Now, let's see what information is hid under the point B and point D. Now, in this diagram, the point B, it is a eutectic point at which CaF2CaCl2 formed. At this point, solid CaF2 and solid CaF2Cl2 and melt are in equilibrium. Means, after application of the reduced phase rule, here in this case, F is equal to C minus P plus 1. This is a formula for the reduced phase rule. If we put the values of the C and P in this reduced formula or reduced phase rule, then we'll get the value of the F is equal to 0. As the F is equal to 0, then the system is a non-variant. Now, the point D. The point D, it is a peritectic point of double compound CaF2CaCl2 at which the peritectic reaction occurs. So this is actually the peritectic reaction in which CaF2CaCl2, which is in solid state, it get converted into or it dissociated into CaCl2, that is in solid phase, and melt is formed. So at this point D, the solid CaCl2, solid CaF2CaCl2 and melt are in equilibrium. Means here you must get the idea about the value of the P, that is number of phase. Here we'll get the number of phase is equal to 3. So by applying here the reduced phase rule, we get F is equal to C minus P plus 1. That is C is a 2, P is 3 plus 1, F is equal to 0. As F is equal to 0, the degree of freedom at the point D is a 0. Hence, the system at this point is a univariant in nature. After the discussion about the points, we'll move towards the different areas. So, in this phase diagram, 5 different areas are present. The first is area above ABDE. Second one is the area AFB. Next, area below CBD. Fourth one is the area below HD. Fifth one, area EDG. And sixth one, area below DG. Now we see how these what informations are given by each area. The first is the area above ABDE, means area ABDE. So this area in which it consists only the melt or the liquid. The next is area AFB. Where is it? Here, AFB. In this AFB area, the solid CaF2 and melt is in equilibrium. The next one is a area below CBD. Here is the CBD. This is the area in which the solid CaF2 Cl2 plus melt are in equilibrium, as this is indicating by this arrow here. The solid CaF2 CaCl2 plus melt are in equilibrium. Now the next one is the area below HD. This is a line in which below is this area is there. So in this area, the solid CaF2 Cl2 and solid CaCl2 is in equilibrium. The next area is area EDG. Area EDG. So as here the arrow indicating there is a CaCl2 and melt is in equilibrium. And the last one is the area below DG. Area below DG. Here this arrow is there for indicating CaCl2 which is in solid state and Eutectic D are two phases in equilibrium. So here in this module we discussed the phase diagram of CaF2 CaCl2, in which we discuss the various curves, different points and the areas. Now the discussion about the module number 7 is end. Finally, important to note, please download the uploaded study material of this module for further study. Please submit the assignment of this module in given stipulated time. And please provide the valuable feedback and suggestions about this module. Thank you for watching this video. In next video, we'll discuss the important concept of the phase equilibria. Thank you once again.